All right, let's talk about harmonic motion. The most obvious example of harmonic motion is a spring hanging on a weight. And if you think about it, if you lift it up and let it go, it just bounces up and down. It cycles between a maximum and a minimum. We're going to ignore friction, which is what causes it to eventually stop. But this actually, think about it, it goes up, it comes down, it goes up, it comes down, it goes up. And if you're ignoring the friction, this really looks like a trig function. So what we're going to do is we're going to define a couple spots, and we're going to say that um, at rest, the spring has a position of 0. That the maximum stretched position down here, if I drag the spring down and stretch the spring out as far as it will go, is a position of 5. And we're going to say that at time 0, we let this go. So we pull it all the way down to 5, we let it go. And when it bounces up, when it reaches the top of its travel, we're going to say that this is a position of -5. So notice we're defining down as positive, up as negative. So here's what we know is that the position at any time t greater than or equal to 0 can be written as s of t equals 5 cosine of t. And, if you need a little convincing, we think about what we've got here. Well, at time 0, it's at a maximum, and then it's going to travel down, and at some time, it's going to be at a minimum, and it's going to travel back up and go to the maximum. So because it's starting at a maximum extension, we use cosine for this one. So here's what we want to do. We want to find the velocity at time t. Well, we know that the velocity is equal to the derivative of position. We know that the constant multiplier rule says we can just leave the 5 out front, and the derivative of cosine is negative sine. So the velocity at any time t will be -5 sine of t. And let's think about that. When I'm at time 0, down here, my weight's not moving. It has reached the bottom and it's going to stop and change direction. When I am headed upwards, so why don't we go ahead and do this one in red? I'm headed upwards, which is a negative velocity. And then when am I going to reach 0 velocity again? Well, I'm going to reach 0 velocity again when I get up to here, because it's going to come all the way up to the top and stop so that it can go all the way back down again. And now I'm going down, which is a positive velocity. And notice that we have a nice negative sine curve here with an amplitude of 5. So let's talk about acceleration very briefly. What do we know? We know that acceleration is the derivative of velocity. So we've got the -5, which is the constant, and the derivative of sine is cosine. And so again, the acceleration, if I think about where I am at time 0, I'm going to have a negative acceleration. Well, why do I have a negative acceleration? Because the tension on the spring is forcing it in an upward direction. So my acceleration is upwards when I'm right here. And then as it progresses, when I get up to here, the spring is compressed and now it's forcing it back down again. And so here's my maximum positive acceleration. That spring is all the way compressed, and then of course comes back down and cycles through. So what do we know about the motion of this weight? Well, We know that it has an amplitude of 5 if we think about the work we did in Algebra 2 about sine graphs, y equals a sine of b x minus h plus k. Oops, forgot parentheses there. We have an amplitude of 5. Half of the distance from the very top to the very bottom. We have a period of 2 pi in this case because there is a b value of 1 right here. In other words, there's no particular stretch factor, or excuse me, not stretch factor, but wow, my head just went completely blank. You know, the thing that goes in there, frequency, frequency of 1. And a lot of the other stuff I've already talked about. My maximum velocity is going to be 5, and my maximum velocity is going to be right here, because that's when it's been accelerated all the way up. The spring's been pulling and pulling and pulling, and then we get to the point where the spring starts to push. So now it's going to start slowing it down again. Speed, obviously absolute value of velocity. I'm not going to write down all the possibilities, but there's a lot of things you can think about here, is especially if you create all these graphs and then think to yourself, okay, where's my maximum velocity? Well, that's up here. Where's my maximum speed? Here and here, et cetera, et cetera. All right, for those of you in my class, why don't you pause the video and do exercise 11 from section 3.5. And we'll come back with the next video and talk about another feature called jerk.